Hello. I thought I was alone. How are you? Are you there? Can you hear me? Hi. Hello. Can you guys hear me? Am I going to be alone in this conversation? Audible, can you hear me? Okay, thank you. We're going to start just now in 5 minutes. Please make sure that you complete the feedback form. For some reason, I cannot post the attendance register. Fail to send. Fail to send. I don't know why. Can you guys see the attendance register that I've posted? Can you see the attendance register?
Where have you posted it?
I am trying to post it on the chat, but it's refusing. All my messages are failing. I'm gonna go out and come back again. I don't know, maybe it's my... Sorry, help me. I can't post in the chat. It keeps on saying failed to send. So please post for me the attendance register, and then I will call and come back at 7 and post the feedback form for me. Thank you. Hey, someone will assist me just now with the links to... Okay, so Claudine will post the link for us in the chat in some short while, but that does not stop us from continuing. So we can start with today's session. sure what time it is. Okay, it's 5:06, so we can start with the session. Are you able to see the presentation? I can't see the chat, so you'll have to unmute and tell me if you are able to see the presentation.
Yes.
Thank you. Okay, so we can continue with today's session. Today's session is mainly about analysis of variance, but I also want to do in the next 30 minutes to do one section of the inferences that we didn't cover in the previous sessions. And this is looking at the inferences about the variances. Remember the previous sessions, we were looking at the inferences about two population means, and we looked at whether they have paired matches or independent, or also the proportions. Today, for this next 30 minutes, I just want to do the inferences about the difference between the two populations, but looking at the variance and how to solve the equations or hypothesis testing in that regard. And then we will continue and do the analysis of variance, where I will look firstly with the basic, and then we will take a 10 minutes break, come back, then look at analysis of variance, where we look at the randomized block design for the last hour. Okay, so to start with, we're going to look at the variances of two independent populations, but we're only going to concentrate on the hypothesis testing. So by the end of this 30 minutes, you should be able to know how to use the hypothesis testing to compare the difference between the variances of two independent populations. Like with the previous sessions, remember the 6 steps of hypothesis. Step number 1, to state the null hypothesis and the alternative hypothesis. Step number 2, to state what you are given. Step number 3, to determine what kind of a test it is. Step number 4 will be to find the critical value. Step number 5 is to calculate the test statistics. Step number 6 will be to make a decision using the critical value and the test statistic, and make your conclusion after that. So the same steps will continue, especially since while we're going to be doing hypothesis testing. So let's look at the hypothesis testing for the variances. So the hypothesis, the null hypothesis, will state that the two variances from the first population and the second population are equal. They are the same. The alternative will say they are not the same. Remember, also the alternative, they can either be, if they are more than, population 1 might be bigger than population 2, or population 1 will not be equals to population 2, or population 1 can be less than population 1. And for all of them, you need to know how to find the critical values for all 3 of them. So how to find the critical value when the population standard deviation, or when the population standard variances are not equal, which means when you are doing a two-tailed test, how to find the critical value when it is one-tailed test. And for the test statistic, we're going to be using the F-test. And because if we're using the F-test, then it will be the sample variance for 1 divided by the sample variance for 2. And that's how we're going to solve the test statistic. So since we're going to use the STA, where your S1 will represent your sample variance for population from population 1, and S2 will refer to your sample variance from the population 2. And all this, when we look at the F table, we're going to be using the degrees of freedom, and our degrees of freedom will be N1 minus 1 times N2 minus 1 as your degrees of freedom. So you will have 2 degrees of freedoms And you will see also when we go to the table, the F table, you will see that there will be 2 degrees of freedoms, but the table is divided in terms of the values of alpha as well. So I'll show you the table just now. So how do we then find the critical value for this F distribution? So to find the critical value, like I said, we're going to use the degrees of freedom for 1, which will be on the table, they are called V1, which will be your degrees of freedom from your population sample size 1, which is N1 minus 1. And also we're going to use degrees of freedom 2, which comes from your sample 2. And on the table, it will refer to V2. And that will be N2 minus 1 for that degrees of, for the, when we look at the critical value. And remember as well, so if it is a two-tail, if it's a two-tail, then it means we're going to find the region of rejection by using alpha divided by 2. And what you need to also remember is that with the F table, there's only one side of the rejection table. So which will mean for a two-tail test, we're going to divide our alpha by 2 and use the degrees of freedom. And for a one-tailed test, we're going to use our F alpha when we look at when the sample, the population variance is greater than. Okay, so let's look at an example, and so then we can go and look at how we find the critical value on the table. So you are a financial analyst for a brokerage firm. You want to compare the dividend yield between the stock listed on the New York Stock Market and the NASDAQ. You collect the following data, and here we have the data for the New York Stock Exchange, and then we have the data for this NASDAQ. And the question we want to answer is there a difference between the variances between the New York Stock Exchange and the NASDAQ at alpha 0.05? So that's what we want to test. So we're going to state our null hypothesis and our alternative hypothesis. Then we're going to determine what we are given. Then we're going to, we know that we're going to be using the F test because we're doing the difference in the variances. And we're going to find the degrees of freedom for degrees of freedom for 1 and degrees of freedom for 2. And then we're going to find the critical value. Now, the other thing that you need to pay attention to is they have given you the standard deviation, not the variance. So we're going to take these values and square them and put the square to those values. So let's look at how we solve this. So the first step, we do the null hypothesis and alternative hypothesis. Remember, this is just says there is a difference between the two. So it means one is equal. If they say there is there a difference, it means are they the same? Is the variance 1, is it the same as the variance 2? Are they equal? And that's how we state the null hypothesis. Then the alternative will say, so the null hypothesis will state that there is no difference between the two, and the alternative hypothesis will state that there is a difference between the two. So the two are not equal. So the first thing we do is we need to go find the critical value. So finding the critical value, since it is a two-tailed test because of not equal, therefore our critical value, we're going to find it by using F alpha divided by 2. And we know that our alpha is 0.05 divided by 2. That gives us the F of 0.0250. That is our F. So if we take our F alpha our alpha divided by 2, which will be 0.05 divided by 2, will give us 0.025. And that will be the value we will use on the table. So let's go look for the value on the table. I will have to stop sharing so that we can go to the F table. Okay, let me stop sharing. I should have shared my screen, not my entire screen. So, share the. Okay, so what I've also forgot to do is to do the degrees of freedom. So we will also use the degrees of freedom. Our degrees of freedom for N1 was 21 from the data set, and N2 was 25. So let's go to the table. Okay, so we need to look for the critical values of F distribution. I need to pivot the table around, rotate it clockwise, and go to the beginning of the table. And this is the beginning. So the table is broken down by the alpha value, and you will see that these are the alpha value. And at the top, we will have the degrees of freedom for 1, and going down on the left, we'll have the degrees of freedom for 2. So, but we're looking for F. Remember, we're looking for F of 0.025. So this is 0.05. So we need to go to 0.25. This is still 0.05. We need to scroll until we get to 0.25. And there is the 0.25. So we know that we're looking for F 0.025. And the degrees of freedom for 1, which will be our V1, it's N1 minus 1. And our N1 was 21 minus 1. Therefore, our degrees of freedom will be 20. And we also need to find the degrees of freedom for 2, which we will call it F2, which is N2 minus 1. And it was 25 minus 1. And therefore, it is equal to 24. So it means at the top, we must look for 20. On the left, we must look for 24. And if we go to the top, there is our 20 is the last column. And for the degrees of freedom 2, we need to go find 24. And there is 24. And I hope I'll draw the line carefully without going to the next row. And the answer is 2.33. That is our critical value. Our critical value will be 2.33. So going back. And you can see that our critical value was 2.33. And that's how we find the critical value. So you will need to use your F alpha divided by 2 because it is a two-tailed test, and we use the degrees of freedom. And remember the degrees of freedom on the table. This one will be V1 and this will be V2. Okay, so calculating the test statistic. Remember the F stat is your sample variance for population for the sample 1, for the sample 1 divided by the sample variance for the sample size 2 And we were given the standard deviation, which was 1,30. So we need to take the square of that value so that it becomes a variance. And for NASDAQ, it was 1,16. So we take the square, and 1,30 square divided by 1,6 square gives us 1,256. Then we take our critical value. Remember, this is our decision graph. So if we plot our decision graph and we put our critical value here, we know that it was 2.33. Anything that falls in the red area, we reject the null hypothesis. Anything that falls in the white shaded, in the white area, we do not reject the hypothesis. So we look at 1,256. Where does it fall? It falls in the white area. Therefore, we do not reject the null hypothesis, and we can conclude that there is not sufficient evidence that of a difference in the variances at alpha, 0.05. And that's how you will apply the F-test. Okay, that's what I wanted to cover. So then we can continue with what we're supposed to be doing for this week. So far, you should learn how to perform the F-test for the difference between two population variances. Any question? We're not going to do any exercises. Any question? If there are no questions, are there any questions?
No.
Claudine just posted the link to the register. Please make sure that you complete the register. So in the absence of questions, then we can move on and do analysis of variance. By the end of this session today, you should be able to know how to apply the basic concept of an experimental design. You should be able to know how to use one-way ANOVA analysis to test for the difference among the means of several populations. You should be able to know how to use a randomized block design and how to use the analysis of variance and to interpret the iteration effect, and also to perform the multiple comparison of the analysis of variance, especially when we look at the two-way analysis of variance and the randomized block design. So what do all this encompasses when we talk about the analysis of variance? So with ANOVA, which is analysis of variance, we're going to look at how we apply the F-test. I'm not going to cover all the things from here. Some of the things you will have to go and learn on your own because we only have 2 hours. And if I look at what analysis of variance has, it might take us forever and ever. So for example, the Turkey-Kramer multiple comparison, I do not cover, and the Levine test of homogeneity, I do not cover. It's easy to understand. Once you understand how to do the F-test, you can do both of those values as well, the other, because they use the same measures from the analysis of variance. Then we're going to look at the randomized block design, and then also look at the basic iterations and see how far we get by the end of the session today. And if, for example, you're still unsure about some of the things, please do not hesitate to ask. You have access to me on the WhatsApp. You have access to the email. So please make sure that you do talk to me if you do not understand any of those things that I am leaving out. Okay, so what is analysis of variance? We use it to analyze or evaluate the difference among the means of 3 or multiple groups. For example, if there are accident rates for the first and the second and the third shift, expected mileage for 5 brands of tires, we can use that to determine if there are any difference in those shifts as well. We can test for that. So when we apply the analysis of variance, there are several assumptions that needs to be met for us to be able to do the analysis of variance. 1, the population needs to be normally distributed. 2, the population have to have equal variances. 3, the sample that we are using have to be from a randomly selected sample, and they need to be independently drawn or selected. And if all those meet all the assumptions, then you can do an ANOVA. When we do the hypothesis for the ANOVA, because we're comparing the differences between 2 or more groups, so there can be more than 1, so more than 2, sorry. There can be more than 2 groups that we are comparing. So we need to make sure that when we state the null hypothesis, we say all the groups are equal. So it means the mean for 1 is equal to the mean of 2, is equal to the mean of 3, is equal to the mean of up until the end of all the populations that we have selected. So if we have 5, we'll say the mean of 1, mean of 2 is equal to mean of 3, is equal to mean of 4, is equal to mean of 5. So all 5 of them will be equal. And with that, for the hypothesis testing, when we look at the alternative hypothesis, at least one of the population needs to be different. And it does not mean that all population means are different. So population 2 and population 4 can be the same population, but at least one of them will be different from the other. And that's how you will state your alternative. And your alternative will say not all population means are the same. That is your alternative. If we look at it in terms of the effect, so we know that we state the null hypothesis as the mean of all population mean are the same. And the alternative will state that not all population means are the same. Therefore, it means if the null hypothesis is true, all means are the same, then it means all of the means, even though, like, for example, if you look here, we have 3 lines. You see there are 3 different populations. So the first population, which is the lighter greenish, bluish line, is smaller than the darker bluish, and the one which is purplish, it looks like it has more deviation than the others. But when you look at the mean, all the means for all these 3 populations will be exactly the same. Then that's all what the analysis of variance is trying to test. So that is, if we say they are not the same, all of them, they are not the same. So we'd be doing a 2-tailed third side. If it's one tail, if it's on at least one of it, one of the population means. So for example, if you look at the 3 graphs, the lighter green and the blue, the means for those are the same, and the purple one, the mean is not the same. And that is the other way of also stating your alternative hypothesis. Or it can also mean that all 3 of them are different. They've got different means. So we need to test and see if that is true. And to do all this, we then use what we call the partitioning. So what it does with the partitioning, we look at the variation between all the groups. So we will calculate the total variance, and that total variance can be split into 2 parts. It can be split in terms of the total sum measures of among the group. So among the group meaning within mean number one, within mean number, oh, not within, among. So everything that is among mean number one, everything among mean number two. Then it can also include the variation within the group. So within the group will mean within all the individual groups that we can calculate the sum square measures within those. And both the among the group variation plus within the group variation, they all account towards a total variation. You will see the formula. We will look at how we calculate all this at a later stage. So how do we then calculate the total sum square measures? So the total variation, we know that it's given by the sum square measures among and the sum square measures within, but we can also use this following formula, which is the sum of the sum of. First is to sum the observation of I and j minus the sample means of the groups. So what that means, it means the grand means will mean for every group of the sample. So for sample one, we will have the mean, sample two will have the mean, sample three will have the mean, and then we calculate the grand mean, which is this X with the double bars. Your J will represent the number of observation within group J, and your I will represent the observation from group J as well. So let's do it visually so that you can see what I am referring to. So let's say we have the three groups, right? So this is group one, group two, group three. So within group one, these are the observations within that group. So we calculate the mean of those, and then we get the average mean for that. And then we also do the same and calculate and get the average mean for it. And then also calculate the mean and then get the average mean for it. And that will give us the average mean for all the group. And when we say the average within the group, this is the average within this group, within this group, within that group, will give us those observations within those groups. Okay. And that will give us the total variation. So what we do is we take this observation minus the grand mean. That observation mean, observation value minus the grand mean. That observation value minus that mean. We add all of them together, and we do the same with the next one. We add them all together. We do the next one. We add them all together, and it will give us our total variance. To calculate the sum square measures among, which is the among group variation, we use this formula, the sum of our n. So our n is the number of groups. So the sample sizes from the groups. So there are three groups. So we count the three groups in terms of the one that we just looked, the example that we used. And we take the mean of every group from every group minus the grand mean squared. So we will take the mean of every group minus the grand mean, and then we square the answer. The sum of all of them will give us the sum square measure among the group. Okay, what do we mean by that now? So if we look among like the variations among the group, you will see that if this is group 1 and this is group 2, you will see that this mean is there and the mean is there. So the mean are different. So, but if we want to find the variation amongst all this group, we will have to calculate it by using the mean of this group and the mean of that group and finding the difference between the grand, because we will have to take those two means, add them together, divide by 2 to get the grand mean. And it will tell us the variation of those means away from the grand mean. And that gives us the sum square measures among. We take the sum square measures to calculate what we call the mean square measure among the group by taking the sum square measure and the degrees of freedom, so which is our MSA, our mean square measure is given by our sum square measure among the group divided by the degrees of freedom, and the degrees of freedom will be the number of observation within that group minus 1, or the number of group minus 1. So that will be our degrees of freedom. So if there are 1, 2, 3, 4, 5, 6, 7, 8. If there were 5, then it will be 5 minus 1. If there are 6, there will be 6 minus 1. And we will look at the example in more detail at the later stage. So in visual, what we're referring to, remember now we take the mean. If we go back, remember we use the mean of every group that we have. So what we do now, we take the average of group 1 and we use the mean of that group 1 to find that difference. And we do the same with group 2. We calculate the average of all within and calculate the difference. And we do the same with group 3 and subtract from each one of them. And that is, so our n, for example, for 1, our n will be 1, 2, 3. There are 3 of them, and for this there will be 1, 2, 3, 4, and for this one there will also be 4. Your n will be equal to 4. Okay, so now let's look at how do we calculate the within the group. Remember now we were looking at among the group, so we were looking only among the group. It's group 1 separate, group 2 separate, group 3 separate. So now we're going to look at within the group. So to calculate the variation, the total variation, remember we're using the sum square measure among plus the sum square measure within the group. So now let's unpack the sum square measure within the group. The sum square measure within the group is the sum of your observation from the groups minus your mean of the group. So now we're not looking at among the group, we're looking only within. So within group 3, we're interested in what is happening within group 3 only. Group 1, we're looking at what is happening within group 1 only, what's happening in group 2 only. And that is the within the group. So if this is a group, we just look at the variation inside that one group. And that's what we're looking for. And we do this for each group separately. Then we add all of them. After we do them separately, then we add all of them. And we use this sum square measure within the group to calculate mean square within the group. So our mean square within the group is given by our sum square measure within the group divided by the degrees of freedom. And the degrees of freedom for this is how many groups do we have minus the number of observations within the group. Okay, visually, this is what we're meaning. Remember that one we had the grand mean where we do all the groups together. Now we're only interested in the mean within this group, we calculate the mean for it. We do the same for group 2, we calculate the mean for it. We do the same with group 3, we calculate the mean, and then we add the mean plus the mean plus the mean. And that gives us the within, or the variation within the group. Okay. Then when we have the mean square measure, when we have the mean square among the group and the mean square within the group, we can calculate the mean total variation, the mean square total variation. And that is given by our MST. Mean square total variation is given by our MSA, which is among the group, divided by our mean square is given by the total variation, SST, which is the total variation, divided by your degrees of freedom, and your degrees of freedom will just be n minus 1, which is the number. How many number of groups do we have? Minus 1. So if we have 3 groups, then it will be 3 minus 1. And that's mean square total variation. So when you have all these measures, your sum square among, you are able to calculate your mean square among. And when you have your sum square within, you are able to calculate your mean square within. And your total variation, you are able to calculate the mean square total. And all this helps you to build what we call an ANOVA table. And with an ANOVA table, it's built in this fashion. It gives you the source of variation, which are the two, among the group. It gives you among the group, and it also gives you within the group. And this, we call them the source. So this will be your source. And then with the source, remember A plus W will give you your total variation. So you will always have your total. And then you also need to be aware of the degrees of freedom. Your degrees of freedom for within is your C minus 1, and the degrees of freedom for W will be N minus C, and the total degrees of freedom will just be N minus 1. And remember, it also includes the values of your sum square measures. And your sum square measures will include your sum square among, your sum square within, and your sum square total, which is your total variation. And when you have your sum square, remember that what we just unpacked, we said we are able to calculate the mean square. And we know the mean square, we can calculate the mean square among by using SSA divided by C minus 1, the degrees of freedom. And we can also calculate MSW, which is the mean square within, by using sum square within divided by the degrees of freedom, which is N minus C. Once we have all this, we are able to calculate our F test, which is our F stat. And our F statistic, we can calculate it by using our mean square among divided by our mean square within. And that will give us our F statistic. C will represent the groups. How many groups, the number of groups do we have? That is C. N will represent the sum of the sample sizes of all the groups. So if group 1 had 10, group 2 had 20, group 4 have 30, so N will be all of them together, is the sum of all the sample sizes. C will just mean that we only have 3 groups. N will be 20 plus 10 plus 20 plus 30. That will be our N. And the degrees of freedom, they are all defined within the table as well. So for among the group, the degrees of freedom is your group minus 1. Your within is the total sample size minus number of groups, and your total variation will be your total sample size minus 1. Okay, so enough with building the table. So now you know how to build this table. Now let's apply the hypothesis testing, because the ANOVA table, we built it in order for us to be able to calculate the test statistic. So we have to go through all this pain to just calculate this F statistic. We still need to go to find the degrees of freedom as well, or sorry, the critical value as well, because we're doing hypothesis testing. So for example, when we state the null hypothesis, remember we say the mean are equal. The alternative will say at least 2 populations are different, meaning at least 2 of those are different from the rest of them. To calculate the test statistic, remember we need to use mean square measure among divided by the mean square within. And all this, they need to be calculated from the sum square measures. And we also, because we will need to go and find the critical value on the table, we will need to use the degrees of freedom. Now, your degrees of freedom, we use the degrees of freedom, your degrees of freedom for 1. Remember our V1. On the table, we're going to be using V1. So degrees of freedom for 1, it relates to the amount. So it will relate to C minus 1, and the degrees of freedom for 2, which is V2 on the table, always relates to within. And it will be N minus C. You just need to remember all those. So when we go to the F table to look for the critical value, you need to know what your degrees of freedom 1 is, which is V1, what your degrees of freedom 2 is, which will be V2. And you will be given alpha to go find the critical value. And once you have found the critical value, you will use that to create a region of rejection. And if it falls, or if your test statistic is bigger than your critical value, we reject the null hypothesis. If not, we will not reject the null hypothesis. Okay, that's how you're going to interpret the result. So let's look at an example. If you want to see if the 3 different golf clubs yield different distances, you randomly select 5 measurements from the trials on the automated driving machine for each club. At alpha 0.05, is there a difference in the mean distance? So it means we need to test whether club 1 is different from club 2 is different from club 3. That's what we need to be testing. So if you look at this, we can draw a scatter plot of this table. But before we draw the scatter plot, we first quickly calculate the mean for club 1. We get is 249.2. We calculate the mean of club 2, which we find it's 2260. We calculate the mean for club 3, which then gives us 205.8. Remember, the mean is the sum of all the values divided by how many there are. To calculate the sum, the mean, or what we call the grand mean, remember the X bar, the X with the 2 bars is taking all this, 249.2 plus 226.0 plus 205.8, divide by 3 because there are 3, and you will find that the mean is 227. So let's say we plot this. So the orange one, this one represents the pink ones. So the mean one for club 1, you can see there, and there is the mean for club 1, and these are the values for club 2, and we can see the mean for club 2. And we also do the same, and that's all what we've calculated. So the line represents all these means. Then the big line represents that mean plus this mean will create the mean. So once we know this mean, the sum mean or the grand mean, then we can calculate the SSA. Remember that. The sum of your observation minus the grand mean squared. So we take all this observation, subtract from the square, plus all that observation, subtract from the square, something like that. We take the mean. So we take the mean. So let's go there. We will take the mean. Remember the mean, we calculated it for every one of them. So the mean, and we know that there are 5. 1, 2, 3, 4, 5. So our n is 5. So there are 5. So we take the mean. So it will be n times. So our n is 5. N times the mean minus the grand mean squared plus the mean minus the grand mean squared plus the mean until we do all 3 of them. And that will give us among the group. And the answer is 47116. Then we do the within. Remember, within is your observation minus the mean. Because we're doing within the group. So we take 254 minus 249 squared plus 263 minus 249 squared plus 241 minus 249 squared plus 237 minus 249.2 squared, 251 minus 249 squared, plus you go 234 minus 226 until you repeat everything until you get to 204 minus 205 squared. And you add all of them, and that will give you 119.6. And that is within the groups. So since we have our SSA and our SW, we can then calculate our mean squares. So our mean square for SSA will be the 47216.4 divided by the degrees of freedom. And remember, the degrees of freedom for MSA is C minus 1. And C is the groups. How many groups do we have? We have 1, 2, 3. So the 3 minus 1, and that will be the answer. And the MSW is within the group. So we say how many? We have N1 plus N2 plus N3. There are 15. So that is our N. It will be 119.6 divided by the degrees of freedom, which is 15 minus our C. C is our groups. There are 3 groups. So it's 15 minus 3, and we get 93. So now we have MSA and MSW. We can calculate our F test. Calculating the F test, we know that F test is MSA divided by MSW. So we take 2358.2 divided by 93. And that gives us the F test. And once we have calculated all this, then we can go to our hypothesis and do what we know about hypothesis. Step number 1, state null hypothesis and alternative. The mean are equal. Alternative, means are not, at least one of the means are not equal. We state what we are given. Alpha is 0.05. The degrees of freedom for 1, remember degrees of freedom for 1 corresponds to the degrees of freedom for V1, it corresponds to the degrees of freedom for among. And the degrees of freedom among is C minus 1. So C, there are 3 groups, 3 minus 1 gives us 2. The degrees of freedom for F2 corresponds to the degrees of freedom V2 on the table, and it corresponds to the degrees of freedom for within the group, and we know the degrees of freedom for within the group is N minus C. So N is 15, C is 3, so 15 minus 3 is equals to 12. We take our alpha and our degrees of freedom, we go to the V table. We remember that, so we go to the F table. So we know that our alpha is 0.05. Our V1, which is the degrees of freedom 1, is 2. And our V2, which is our degrees of freedom 2, is 12. If we go to the table, if we go to the table, our F table, remember the F table, we're going to look for alpha 0.05. Remember this one we were using, it was 0.025, so we need to go up to 0.05. And this is 0.05. If you look at the table, this is continue. So it starts from 22 till 180. Our values are small, so it means we must go up again to the next table. And this is our table that we're going to be using. We reduce the size of the table. Okay, we don't need a lot. So we know that we're looking for F 0.05 and the degrees of freedom F V1 of 2 and V2 of 12. We know that we are on the right table because our alpha is 0.05. Our V1, which is the value at the top, our V1, we're looking for 2, and that is our V1. Our V2 is equals to 12. That will be 12, and that will be the value we're looking for. So therefore, our critical value will be 3.89. So we find our critical value, which is 3.89. We create our region of rejection. Anything that falls beyond 3.89, we reject. Anything in the white area, we do not reject. So we've calculated our F test. Remember, we calculated it before. So we found that it was 25.275. So we calculated that. And we take this value, we go and look on the table. This is 3.89. It will fall somewhere that side of the red shaded area. Therefore, it falls in the rejection area. And the conclusion will be we reject the null hypothesis at alpha 0,05 and conclude that there is evidence that at least one mean differs from the rest of the means. From all these values that we just calculated, including the F-test, we can complete an ANOVA. This one is an ANOVA from an Excel output. So if we look at this, it gives us the source, which are our groups, and it gives us the count value. It gives us the sum of all the values within every group. And if we take the sum divided by how many there are, it gives us the average, which is the mean. And we can calculate also the variance if we want. Then the ANOVA table, if we complete the ANOVA table, we say the source will be between the group and among the group means the same thing. So we can use between instead of among, so they will still mean the same thing. So between the group, it means between all three groups. We calculated the sum square measures. We calculated the degrees of freedom. We know that it's C minus 1. There are three groups. Minus 1 is 2. We calculated the sum square measure for within the group, and we found that it was 11119.6, and the degrees of freedom was 12. The mean square measure, which is your sum square divided by the degrees of freedom, gives us 2358.2, and 119.6 divided by 12 gives us 93. Calculate the test statistic, our F test. We take the between the group 2358.2 divided by 93.3 gives us 25.7. The others, critical value, we find on the table. The p-value, you calculate, the computer generates that. And this is 0,0000 some number, because there are 4 zeros after the comma. So there is 1 zero before the comma and 4 zeros after the comma. So that will be 0,0000499. And that's that value. And the total, we just add all of them to create total. And this is the Excel output. Sometimes you might be given a Minitab output, and they might ask you to answer certain questions relating to this. So it also looks exactly the same. Degrees of freedom, sum square measures, mean square among, and mean square within. Our F test and the p-value, it would have calculated it. And this is your degrees of freedom for total variation, and this is your total variation, which is the sum of your sum square within plus your sum square among. So if you look at these values, so different tool creates different output in terms of the source. So in this instance, among is the claps, and the error is your error will be your within. So your within is equivalent to errors. So you just need to know how you look at the table and what does every one of them mean. Okay, so that was just an example. If this was a exam paper and they ask you to calculate the ANOVA, so now if you look at this table, you can see that they have left out some of the values out. So you will have to complete the table before you can answer any of the questions below. Some of the questions below or the options below refers to the missing values that you are looking at. So based on this, the first thing you need to do is to calculate your degrees of freedom So you will have to calculate these degrees of freedom. Remember, what is this degrees of freedom? It's n minus c. But remember, we also have a total. So to calculate this degrees of freedom, which is n minus c, we can also use total value minus the treatment. You can use total value minus the treatment, and that will give you for your degrees of freedom. So for that value, you will take 41 minus 6, and that will give you your answer. Once you have that, you can also do the sum square. It's the same thing. You take your total value minus your sum square value for treatment, and that will give you the missing value. Then you will have this table complete. Now you need to calculate your MS. Here they only give you question mark on MS treatment. You need to also calculate this MS in order for you to calculate the F statistics. So to calculate the first MS, you will need to use SS treatment. I'm going to call it treatment. SS treatment. Why can't I write today? SS treatment divide by your degrees of freedom for treatment, which is 6. And to find this one, you will say SS error divide by the degrees of freedom for that. To calculate the F stat, so you will use the F stat, you will say the answer you got for the MST in terms of treatment, and the answer you got for MSE. So I'm going to say MST divided by MSE. Remember, this is treatment. Let me put it like that so that you don't get confused between MS total and the treatment. So you need to use all those values. So first, calculate the degrees of freedoms for error in terms of the degrees of freedom. Then you must calculate also the sum square measure for the error, and then calculate your MS error, MS treatment, and also MS error. And once you have the values for MS treatment and MS error, then you can calculate the F stat, the F test, and then we can answer any of these questions. I'm gonna give you 5 more minutes. Remember, if you have the answers, you can also write them on the chat. If you are able to write them on the chat. And don't forget to complete the attendance register as well. Okay, how far are we? Are we done? Did we try at least? Did we get it? How are we doing? Talk to me. Okay, so you decided to boycott me. It's fine. I will learn on my own. Okay, so degrees of freedom, 41 minus 6. So I'm just going to continue and answer the questions as well. So the number of treatments involved. So we know what the degrees of freedom for treatment is C minus 1. So how many number of treatment would have been to make it 6? It means there would have been 7 minus 1, which gives us 6. Therefore, there should be 7 treatment. And in this instance, it says there are 6. So that will be the incorrect value. The total sample size, N, is equals to 42. If I look at the sample size here, it shows me 41. I know that for treatment, the degrees of freedom is given by N minus 1. Therefore, this should have been 42 minus 1 will give us 41. So that would have been correct. The mean square measures for treatment T is 2.9. I cannot calculate. Oh, yes, it's 2.96. So that is given by SST divided by the degrees of freedom, which is N minus 1. So the degrees of SST is 46.5 divided by 41. And that gives us 46.5 minus, not minus, 46.5 divided by 41 gives us 46.5 divided by 41 gives us 1.13. 1.13. And that is incorrect because that says 2.9. So this should have been incorrect. Okay, so let's go to the next. The mean square measure error, which is MSE. In order for us to find the MSE, we cannot find the MSE if we don't find the degrees of freedom. So our degrees of freedom, we said we can just say 41 minus 6. Is 35. Or we can say N we know our N is 42, so 42 minus our C, our C was 7, so we still get the same. So it is 35. Or we could have just said 42 minus 7 will give us also 35. That is our MSE degrees, the MSE degrees of freedom. So therefore this one, we have calculated what the degrees of freedom is 35. Now we need to calculate SSE. SSE is that value there. So to calculate SSE, we can just say 46.5 minus 17.5 will give us SSE, which is equals to 29. This is 29. And 29 divided by 35 gives us 0.82. And that gives us 0.8286. And that is correct. That will be our MSE. Now we need to calculate our F stat. We know that our F statistic is given by MSA, which is MS treatment, divided by MSE. So we know our MSE, we calculated it, is 0.8286, but we don't know what our MS is. So we need to calculate our MS treatment. MS treatment, we calculate it by saying 17.5 divided by degrees of freedom, which is equals to 6. And that gives us 17.5 divided by 6 equals 2.92. 2.92. So we can substitute 2.92. And 2.92 divided by 0.8286 equals 3.52. Equals 3.52. Which one of the following statement is incorrect? Beat me. There are two statements here that are incorrect. Either number one, they made a typo, they should have written it as 7, but they left it as 6. So yeah. Hopefully that does not happen to you in the exam where you get two options that are correct, or you choose the first one, can be the second, the third one is the correct one that they were looking for. Okay, so that's how you answer the analysis of variance. Any question? Any question? So if I go to the chat, dololo, nothing. You guys are mute. You're not talking to me. You're not saying anything. I don't know if you understand or not. I don't know. I don't know. Anyway, let's move on and look at how we do analysis of variance for the randomized block design. Okay, with the randomized block design, like with analysis of variance that we just did, we're going to test for equal population means, but we will also want to control for the possible variation from the second factor that we have. Therefore, it means we're going to use the level of secondary factor, and we're going to call those factors blocks. So to calculate the total variation, because of that block, the level, the factor that we want to include, then total variation will be given by the sum square measure among plus the sum square measure block among the block and the sum square measure errors. So these are your random variation values that we can account for. Okay, so how do we then do this? Okay. Remember the two, the SST and the SSA, the same way as we compute them from the previous session, we continue with that. SSE is your total variation minus your sum square measure among plus your sum square measure block. How do we then calculate these things? So your SSB, which is your block, will be the variation within the block, the sum square measures within the block. So how do we then calculate the mean square? Our mean square block will be given by the sum square measure block divided by your degrees of freedom, which then is your R minus 1, and your mean square error among the group will be SSA divided by R minus or C minus 1, which is the number of groups minus 1, and your MSE, which is your mean square error, will be given by your SSE divided by your degrees of freedom for the MSE will be your R minus 1, which is the number of blocks, minus 1 times your groups minus 1. Okay, so when we look at the randomized block table, it looks exactly the same or almost the same as the ANOVA table, but now because we have the blocks in between, so we account for that in the table. So now your randomized block ANOVA table will look like that. So it will have your source. So your source will be your block. Among the block, it will have among the group, and it will have the error. And then you will also account for your degrees of freedom. Or it will also have the total. So you must not forget the total. It's just the sum of all of them anyway. You will have your degrees of freedom, and your degrees of freedom among the block is R minus 1 because it will account for the number of blocks. And among the block will be C minus 1, and your errors will be your R, which are your blocks, minus 1 times your group minus 1. And your total will be your block times your group minus 1. To calculate the mean square measure or the sum square measures, the SS, the sum square measures, they will be the same. Then we will calculate the SSB, the SSA, the SSE, and the SST. And you will also be able to calculate your MS, which is your mean square measures, and your MSB will be given by your SSB divided by the degrees of freedom. Your MSA will be given by your SSA divided by the degrees of freedom. The SSE will be given by your SSE divided by, MSE will be given by your SSE divided by the degrees of freedom. Then you can calculate your test statistics. So here we're going to calculate the test statistic for the block and also test statistic for the among the group. So your test statistic for among the, so your F for the block will be given by your MSB divided by MSE. And for the other one, which is your among the group, your F test will be given by your MSA divided by your MSE. And that will be the test statistic that we use to find the whether we reject the null hypothesis or not, using the degrees of freedom and your F test to go find the critical value. So we'll use those values, where your C represent the number of populations, so number of groups we have. Your R will represent the number of blocks you will have. Your RC is your total number of observations. So it will be your blocks times your groups will give you the number of observations. And then we'll have the degrees of freedom. Remember your degrees of freedom, F1 or V1. So your degrees of freedom V1, degrees of freedom V1 will be given by C minus 1. The degrees of freedom V2 will be given by R minus 1 times C minus 1. Must not forget that. Oh yeah, I was way ahead of my time. So when we state null hypothesis, the means are equal. When we state the alternative, not all population means are equal. To calculate the F stat, we're going to find the test statistic for the main factor by using MSA. MSA always calculates. MSA divided by MSE will calculate the main factor. And we're going to find the degrees of freedom using C minus 1 and degrees of freedom 2, R minus 1 times C minus 1. And if your test statistics is bigger than your critical value, we reject the null hypothesis. And remember your F, we're going to just use alpha. Okay, so for the block effect, which is the other one, to calculate or to make decision based on the block effect, we say the means are equal, and then not all the block effect will be equal. And we use the F statistic of the MSB divided by MSE with the same R minus 1. So instead of C, now we're going to use our degrees of freedom will be R minus 1 for this instance for V1. And we're going to use R minus 1 times C minus 1 for V2. And if the test statistics is greater than your F alpha or critical value, we reject the null hypothesis. So let's look at an example. So let's say they give us this, and the difference, when they give you the table, they will tell you, they will sometimes explain that randomized block designs or not. They might explain in that way. But when you look at the table, remember, the normal ANOVA table only has 2 rows, has the treatment and the error. So with the block, you will have the third column as well there, so that then you will know that this is a randomized block design. ANOVA table. So given this block design ANOVA table, the question was, can we infer at 5% level of significance that the treatment, so in this instance, we're looking at the treatment, that the treatment are different. So not the blocks, but the treatment. So using this, we state our null hypothesis. Null hypothesis. All the means, mean I, mean j's equals to 0. So all of them. So mean 1, mean 2. So, or we can write it as mean 1, mean 2, mean 3, mean 4. There are so many of them. So mean 1 is equals to, mean 2 is equals to, mean j. Alternative 2, all treatment are not the same. Are not the same. That's our null hypothesis and alternative hypothesis. Step number 2, what are we given? Alpha 0,05. 0,05. Our degrees of freedom of V1, remember, is, because we're doing for treatment, our degrees of freedom is 4, and degrees of freedom for 2 will be for error, which will be 24. So then we can go and find the critical value. Finding the critical value, we're going to use F alpha, which is F 0,05, degrees of freedom 4, and 24. So we go to the table. We come to the table. We are looking for alpha 0,05, that's good. F 0,05, V1 of 4, and V2 of 24. Those are our degrees of freedoms. So we look for 4 and we look for 24. And there is 24 right at the bottom there. So where they all meet, and that is our critical value, is 2,78. That is our critical value. So our critical value, so this is step number 1, step number 2, step number 3, we're doing an F test, so I don't have to write that. Step number 3, we're doing an F statistic test. Step number 4, we found the critical value, F 0,05, degrees of freedom 4, and the degrees of freedom 24. We found that our region of rejection is 2,78. So 2,78. Now we need to go find the test statistics. So going to step number 5, we need to calculate F stat. Since we're doing for treatment, remember that the means for the treatment are different. So we're doing the mean for the treatment. Mean for the treatment is MSA or MS treatment divided by MSE. Remember that. Our MS treatment is that I don't even have to calculate it because they gave me the values anyway, so I shouldn't even have calculated it. MS treatment divided by, so that will give us 1680 divided by 115 gives me 14.6087, which is that value. So I don't even have to calculate it because they gave it to me, which is 14.6087. If you calculate it on your calculator, you will get the same answer. Now we need to take this value and go see where does it fall. This 14.6087. So if I change my ink to blue, so my 14, it will fall somewhere inside this area, somewhere far away from there, inside the area there. So therefore, if step number 6, we reject H naught at alpha equals 0.05, because then the mean, at least one of the mean treatment are not the same. And that's how you will make a decision based on the ANOVA randomized table. So let's look at another example, but now let's look at the block. So when we look at the block, so sorry, this I must change block. So this block, same question, null hypothesis, mean 1 is equals to, mean 2 is equals to, until mean j, and the null hypothesis alternative, at least one mean block at least one mean block is not the same, and that's how you will say. So let's make space, is not the same, it's different. Step number 2, that is step number 1. Step number 2, state what you are given. Alpha 0.05, still the same. Degrees of freedom, remember now the degrees of freedom for R will be 6, for V1 will be 6, and the degrees of freedom for 2, which is V2, will be 24. And step number 3, what kind of a test are we doing? We're doing an F statistic test. Step number 4, we need to go find the critical value. Critical value will be 0.05 and the degrees of freedom of 6 and 24. So totally different from the first one. The first one, our degrees of freedom was 4 and 24. Now it means we need to go and find the degrees of freedom for this one as well. So going to find the degrees of freedom. Finding the degrees of freedom. We're still looking for alpha. So we know that our F is 0.05. Our degrees of freedom is 6 and 24. So on this side, we're looking for 6 at the top. On the side for V2, we're looking for 24. So where they both meet. And this is 251. For the block, it's 251 degrees of freedom. So we go to the degrees of freedom. our degrees of freedom. There we go. We define our critical value, which is, sorry, not the degrees of freedom, but our critical value, which is 2,51. 2,51. Using these degrees of freedom of 2,51, then we can do the following. We can calculate what the F test is. So they've already calculated it. So step number 6, they've calculated our F test, and our F test F stat is equals to 4, for the block, it's 4,5217. So where does this 5,527 fall within the scheme of things? When we look at the rejection area, so this is 4, so 4, something falls somewhere here. So therefore, we reject H0 at alpha equals 0,05, as there is sufficient evidence that at least the mean block are different. And that's how you do the hypothesis testing, or you're going to answer the question. And mind you, in the exam, any step that I just went through might be an option that you have to select as either true or not true, or incorrect or correct, depending on what the questions they are asking you to do. Okay, and that is how you do the hypothesis testing. I wanted to do it manually, but I've already have the slide with all the answers for the treatment. So I'm not going to repeat all this because we just went through, and remember we rejected the null hypothesis for the treatment. And this was supposed to be your exercise. It is 16:44 at this point. So it means we only have 15 minutes till the end of the session. I am going to pause right here, and I am going to afford you the opportunity to ask any question that you have, any uncertainty that you have, any comment about the session. And if there are no comment or question, then it's still okay. Because I cannot force you to talk to me, as it is up to you, as this is your learning. So you're the only people who knows whether you understand or don't understand what I am talking to you about. Your silence only helps you.
Hi.
Yes.
It's been now this session, honestly, I mean, I think you were, I wouldn't say too fast, but you know, to follow through everything, you know, for me catching up, I will have to go and do everything you did today all over again, just to see if what I think I understand is really clear that I understand.
Every week I say, if I'm moving too fast, stop me, tell me that I'm moving too fast, so that then I don't leave you behind. But you guys are quiet. You don't want to even talk to me.
Yeah, no, it's not that. It's just that, okay, for my side, I'm trying to question myself if ever everything that I see here makes like sense. So I need to get, you know, my head around the abbreviations SS and MS, because somewhere when you talk about them, I get lost. So I just need to brush that on and then see how it goes.
Okay.
Hi, Miss Mboi.
Hi.
On my side, the only question that I have is I wanted to know where can we find the previous videos and even the session that we normally do with you, because I've been looking through the UNISA site on the Western Cape one. There's nothing. I can't find anything relating to stats 1502.
Oh. Okay.
Because if we have the video as we are moving on the pace that we are moving in, at least if we have the videos, I'm able to go back and revise like slowly while I'm also doing my assignment as well.
Okay. Let's see if are they not there. The thing is, I don't manage the site. UNISA does that. So my job is just to come here and talk, and then go home or stay home, switch off. And then I expect them to upload the videos. I will check and then I will send them an email. I know that this week they are not working, so they are only back in the office next week. All videos that are outstanding, they can only be uploaded next week. Okay, so others, what are you saying? Remember, I'm here to help you guys. I am not your lecturer, so you can ask me anything. You can your assignments and do whatever with me. I'm here to help you understand your module. That's my job. Or is it job? I'm not getting paid for doing it. That's my responsibility. Let me put it this way. I am doing it for you because I like doing it. I love doing it. I love helping you. And all of the above for free. So you should be abusing me. I don't know why you're not abusing me in terms of asking for help. Because I'm not, nobody is saying pay for asking a question. Nobody. So everything mahala, and you still stay away, guys. Others, what are you saying? So in the meantime, while I still check the video, I want to share my screen now. But before I share the screen, let's do this because I haven't closed the session as yet. I am still sharing the presentation. So this is another question that comes from your past exam paper, so you can go through it and see how you answer it. As you can see that almost all the steps that are here, they just refer to the null hypothesis and the alternative and also the degrees of freedoms, and that's it. So sometimes the questions are easy. They are not as complex. So, but you need to practice. You need to go through the content again and look at how you answer those questions on your own as well. So in summary, while I'm at it, let's do this. In summary, or in conclusion of what we can recap on what we did today, we looked at, first of all, we looked at the independent of population with when we are calculating the variance. And then we looked at the ANOVA. So we looked at the logic behind the ANOVA. We looked at the assumptions, and then we looked at how we calculate the F statistics and make the hypothesis testing. Then we also looked at the randomized block design. And what I also said was there were two other methods that I didn't look at, the Beroni and the Teca. Please make sure that you also go through that content because they also use the same kind of information. For example, they will use the MSEs and the MSAs to calculate some of the measures. So, but you need to know which ones you're referring to as well. Practice makes perfect. This is maths, this is stats. You cannot read it a day before or 2 days before you go write the exam. You need to practice so that you get used to. If you have past exam paper, I think there are 3 past exam paper loaded on my UNISA. Download them, go through them again and again and again and again until you make sure that you understand some of those. So for most of the exercises that we do in the session, they come from your past exam papers as well. And that is how I recap for now. So now, going back, I'm not going to switch off the video as yet, because I want to show everybody how to get there if they are not there yet. So I'm going to share my screen again. Okay, so this is my UNISA. You log in. I'm already logged in, so let's hope it's not gonna disappoint me. So you go to your my UNISA if you have already. You log in. I hope I'm not gonna show you my password. That's my username. It's not my password. Okay. So you log in onto my UNISA, and then you go to my modules, the same way as you go through your modules, and you go to sites. And I have so many because I've been at UNISA for more than, I don't know, a decade now. You go to, there will be a site where it says project. So if you are from Western Cape region and you're accepted to be part of the region thing, you will have the region, Western Cape region on my UNISA like that. So you can also like and make a star on it so it will appear in your favorites. And when you go to the region, so I'm just gonna click on the region, it will take you to this page, which is the Western Cape region page. There are multiple things on the left. You can use any of this. So this is the numeracy class. Today's session is a numeracy class. So you will click on the numeracy center. And there it says enrollment information. We're not interested. There is the schedule. So if you see today is Tuesday, it will have what is happening. So today's session, this is the name of the session of today. And then they have a link to join the session. You should have used this link to join the session. Or if you want to go to the recordings, you click on this where it says notes and recordings. I haven't been posting notes. I forget because it's a mission and I have to go there. So these are the recordings. As you can see, there is a recording for the first, the recording for the second, the recording for the 15th, and that was the last one we had. How many recordings should we have? 1, 2, 3. Today should be the 4th one. So you have all the recordings that needs to be there. They are all there. So you just need to go to the numeracy center, not the tutorial, because this is not tutorials, it's the numeracy class. And all the recordings are here. So today's session, the recordings will only be uploaded on the 28th. So don't go there and look for the recording during this week. They will be there after the 28th. Then if you want the notes, that will be an embarrassment because there are nothing in there. I haven't posted anything. Let's see. Maybe I did post once. I will post all the notes that we use. So now when you go to this one, you will have to sign in again with your my UNISA email address. I don't know my email address by heart. Okay, I know it, but it's gonna ask me to get the code as well. So it's a long process. So you will sign in into the Microsoft SharePoint so that you can have access to the notes. I don't know why doesn't pick it up. So that's where you will find the notes. You have to log in on there. Okay, and that concludes today's session. In the chat function, there is the link to the feedback form. Remember, your session is Quantitative Literacy STA1502, or you can say Numeracy 1502. So your name of a session will always be that name that you see on this meeting notes. Please make sure that you complete the feedback form. So I still can't post on this, but the feedback form was posted by Claudine earlier. Make sure that you all complete that. And thank you for coming through today. And with that, it's my cue to stop sharing.
Okay, thank you.
No problem. If there is nothing else, thank you guys for coming through, and good night. If you haven't completed the attendance register as well, please, there is the link there for the attendance register. Make sure that you complete both. Those two.